All right, this next little video is to help you with a little bit more with the laws of exponents. In this case, we're going to cover the zero power. We're going to deal with like exponents, and we're going to deal with what I call the power to a power rule. So first of all, zero power. The definition of the zero power says that anything raised to the zero power is defined to be 1. I was looking at a pattern one time, and I guess I had something like 2 to the third, which turns out to be 8, 2 to the second, which is 4, and 2 to the first, which is 2, just the powers of 2. And I was looking at that chart or that table, and I noticed if you look at the patterns here, we have the powers going from 3 to 2 to 1. Obviously the powers are decreasing as we go. And as we go from 8 to 4, or from 4 to 2, it seems like we're cutting in half in each case. So if that were the case, it would make sense 2 to the third, 2 to the second, 2 to the first, that the next number in the pattern should be 2 to the 0. And in order to get that, it seems that I should take this number and I should cut this number in half, because I've gone from 8 to 4, from 4 to 2, so I should go from 2 to 1. So if you notice in this case, it just illustrates that something to the 0 power does turn out to be 1. When we're doing problems like this, you might be asked, what is x to the 0 power? By definition, that would turn out to be 1. We could try something like -3 to the 0 power. Again, that would turn out to be 1. So the bottom line is anything to the 0 power is going to end up being 1. The second law is going to be what I call like exponents. And in this case, we'll take 2 to the 4th and we will multiply that by 3 to the 4th. In a previous tutorial, we dealt with the like bases, but in this case the bases are 2 and 3. They're not the same, but we do have exponents that are the same. And if we have something like x to the a multiplied by y to the a, again, don't let the x and the y and the a confuse you, but the x and y just represent that the bases are different, and the a's represent that the exponents are the same. The answer is, if I keep that common exponent and pull that out, I multiply the two bases and raise it simply to the a power. So if that's the case here, I will pull out my common power of 4, and I'm left with 2 times 3 on the inside. Now if I know what 2 times 3 is, it would certainly make sense to change that and write that as 6 to the 4th. So in order to simplify 2 to the 4th times 3 to the 4th, I need to pull the common exponent out and then multiply my bases, or excuse me, multiply the bases. So let's take something like -3 to the 5th power, and let's multiply that by 7 to the 5th power. I've used parentheses in both cases. I wouldn't necessarily need it in this case, but in this case it's also making sure that I remember the parentheses include the negative. Common bases here, or excuse me, common exponents here. So I'm going to pull that common exponent of 5 out, and I'm left with the base of -3 that needs to be multiplied by the base of 7. In this case, that turns out to be -21. I would make sure when I wrote this that I didn't just write -21 to the 5th power, but because the answer was -21 and I want all of that to the 5th, I would make sure to put parentheses around there so that that negative got included as well. So the bottom line in these examples is, if I have like exponents, I'm going to pull that like exponent out and I'm going to end up multiplying the bases in order to get my simplified answer. The last part of this is what I call the power to a power. Power to a power rule, which says if I have x to the a raised to the b, if I have one power raised to another power, I'm going to take x to the a times b. Example of this would be if I have x to the second raised to the third. One power is raised to another power, so my answer then according to this should be these two powers multiplied, which is 2 times 3, or x to the 6th power. In order to make sure that that actually makes sense here, if I remember, a third power means that I should have 3 of all of these multiplied. So that means I should have x squared times x squared times x squared. And now this fits into the like basis situation because all of these bases are x, which says then I should simply add the exponents of 2 plus 2 plus 2, which which ends up being x to the sixth, and that matches up with the answer that we had right there. So just verifying that this is kind of a shortcut that allows me to get around the long version of that answer. Again, if I took another example here and we simplified and we had something like x to the third raised to the negative fifth power, I would multiply those two exponents in this case, and I would simply have an answer of x to the negative 15. Remember, we've worked a lot with negative exponents. That answer might not be available if it's a multiple choice situation where a teacher may say we want all answers with positive exponents, and in this case, if it's got a negative exponent, I can send it to the bottom and make that x to the positive 15, and it becomes 1 over that. These two answers would be equivalent. This is the negative exponent form of the answer, and this is the answer written with positive exponents. So in this situation, we covered the 0 power today. Remember that anything to the 0 power is 1. We also covered the like exponent situation, as well as the power to power rule. And as we always say, if you do have questions, be sure to ask a teacher. Thank you.